Okay. All right. Can we hear me? Just wave if you can hear. We can hear? Okay, very good. All right. So are we excited to work on a statistics worksheet today? I'm going to take that as a yes. Okay, so somebody, does anybody not have the worksheet pulled up? Everybody's got it? Let's see, hold on, somebody's trying. Okay, so Tony Castro will be late today. He has to take a Spanish test right now. Alex, why does he have to take the Spanish test right now?
It's the way our Spanish classes are making us do it. Like, we have to take it during our assigned Spanish, like, class time, and it's a 2-hour test.
That doesn't make sense. But you have this class right now.
I know, that's why I was letting you know that, yeah.
Really?
Like, on Friday, I have to take mine immediately.
So your Spanish teacher is giving you a 2-hour test for a 50-minute class.
Yes.
I will also have that Spanish test.
When is your Spanish test, Stephanie?
Same time as his.
Right now?
On Friday.
Oh, okay. So for us on Friday, we're just taking our quiz, so we're not going to have a Zoom lecture, but I give you, I think, 12 hours to take your quiz. So you just have to take it at some point between 11 a.m. and 11 p.m. So that shouldn't be a conflict, right?
Right. Thank you.
Okay. Okay. So here's what we are going to do. So I'm going to share my screen. I'm pulling up the worksheet right now, and I will share my screen. And then what I'd like for you guys to do is we're going to do the problems one at a time, and then I'll just have you guys either share your screen or turn your mic on, and we can go through the answers. Does that sound good? I'm going to assume that sounds good. Okay. Let's see. Okay. Can we see my screen? Does everybody see the worksheet? Oh, for
yes.
crying out loud. Hold on. Juan is emailing me, and so is Marie. Let me just see what their problems are. Oh, she's on the West Coast. Oh, this is for something different. Is Marie, are you in here right now?
Yeah.
Okay. You're talking about our meeting for later today, right?
No, you said it was at 8 a.m. So that would have been 5 a.m.
That is because I messed up the Zoom invite. Look at the following email where I say, just kidding, this is our invite. And I
Okay.
So yes, okay, I see that. Now let's see what's going on with Juan. Is Juan in here? I see no Juan. Let me just answer his email. Okay. Dealing with that. Okay. All right. So we can all see my screen, right? All right. So let's have us. So problem number 1 is just picking out the, oh, Tony's here. Welcome, Tony. I hope your test went well, your Espanol. Alex told me you're going to be late. So let's see, where's Tony?
Right here.
There you are. Okay, so do you have your worksheet pulled up?
I'm about to pull it up.
Okay, very good. So everybody, let's get our worksheets up. I want you guys to do this first problem, which is actually 3 and 1. So if you guys could fill out the independent and dependent variable for each of these 3, I'll give you guys a few minutes and then we'll have you guys answer them, okay? Oh my God, my husband is talking so loudly on a conference call downstairs. You guys can probably hear him. It sounds like he's screaming. There's 1. One, are you in here? I see a big giant J instead of your face. There's 1. Do you have your worksheet up? I just unmuted you. Do you have your worksheet up?
Oh, yeah. Yeah.
Okay, we are working on problem number 1, which is actually 3 problems or perhaps 6 if you're counting each independent and dependent variable. So get to work on that. We muted you again.
Dr. Hill, I have a question.
Yes.
So we didn't really talk about it yesterday, but when we're finding like the mean and stuff, if the mean is for people, you would want to use a whole number. But if it's for something like age, would you like put decimal points?
Always
If it-
give a decimal point. Even
Even
if
with people?
even if it is for people. Like for instance, a lot of times what I see is like telling, like for instance, I was teaching my corrections class about a prostitution court, and I was saying that the prostitutes have an average of 1.3 children, which obviously makes no sense, but what you can tell from 1.3 is that it's like if I said an average of 1 child, like, I mean, we understand what that means, but always give the percentage, because if it was like 1.7, we would know it was closer to 2. Does that make
Yeah.
sense?
Yeah. Okay. I was just wondering, because when we, in my stats class, when we did it, a lot of times when we were dealing with like people, we would either round up or round down to the nearest whole number, because
I mean, you can, like, I would say, like, maybe in the discussion, I would say that, you know, on average 1 child. But if you're giving it in a table, I would still give the point, like the decimal point, so that they could see about where it falls. Like, we know it's closer to 1 when you say 1.3, right? If you just say
Yeah.
1 or 2, like, even if it's 1.7, 2 is misleading.
Yeah. Okay.
Okay, who's ready to share some answers? let's start with this one. So someone turn on their mic and tell me which one's the independent and then, okay, Hayden.
All right. The independent variable I got was education.
Mm-hmm.
Dependent variable was eyewitness statements.
Very good. If that is not what you got, switch it up. All right, who's ready to answer number 2? Robin.
Yes, I got for the independent variable, I got numbers of hours the individual used on the phone.
Mm-hmm.
And the dependent variable will be eyewitness testimony.
Very good. Very, very good. That's the one where I'm trying to trick you guys, okay?
Yeah, I saw that. I was like,
okay, awesome. All right, who wants to do number 3? Let's see. Okay, Celeste.
Independent would be gender, and then the dependent would be identifying minorities in a lineup.
Excellent. Very good. We always know gender cannot really be a dependent variable. That's not really something we can change easily. Okay, so now what we're going to do is questions 2 through 4. You can go ahead and be really annoyed with me when I'm going to be asking you to give me the median, because you're going to have to write 19 12 times. You're going to have to write 17 10 times. Okay? So let's determine the mean, the median, and the mode. I'll give you guys a few minutes to do that. I hope you have a scrap paper to write out all these numbers for your median.
Can we not just use a calculator for that?
For what?
Median?
No.
I mean, I'm in stats right now, and that's what I do.
Sorry, there is a bird that's, can you guys see the bird that's slamming into my window?
Our birds should start doing
You
that.
I can
see
hear
it
it.
up there?
I can
does
hear it.
all the time. I don't understand.
Close the blinds. He's trying to get through the window.
I think he's using
can't close.
reflection.
First of all, the blinds are laced, so that's not going to do shit. And second of all, I've got this desk pressed all the way up against the wall. I don't know what he's trying to get at, but it like scares the shit out of me every time. Okay, let's move past the bird. And no, you can't. You can use a calculator for the mean, but you need to calculate the median and the mode by hand, okay? Because I think it's 1700s.
I had a question.
Yes.
Okay, if you get the little decimal, could you round it?
Yes, I would like for
Okay.
you to give me at least 2
Okay, I
decimal
rounded
points.
it. Okay, I rounded. Okay.
Well, let's see. Let me see what I did over here. Yeah, I went to the 100th place. The bird went away.
How many decimal places do you normally use?
2.
You.
Hmm?
How many decimal places do you normally use?
2.
2. Oh, I thought you said who.
Oh, that doesn't make sense, Mason.
got another question.
Yes, Robin.
Yes, I'm confused. I'm on number 5. I'm trying to see how do you start to do it. Like,
Don't do 5 yet. We're doing 2
okay,
through
wait.
4.
Okay.
Hold on.
Okay.
Is everybody done with 2 through 4? Are we ready? Taylor's not ready. Okay.
I messed up big time on like 2, and I had to completely redo it. And I don't even know how I got the number I got.
All right.
Okay, I'm good.
Okay. Who is ready? Who wants to give me the answer to number 2? I can't see you guys all at once. Who has not answered yet?
16.91.
Very good. That is exactly what I got as well. Did anybody get anything different? No, that's what we got.
When I
Okay.
messed up, I got 85.84.
Yes. Did you just add up these numbers first? How'd you get that number?
I don't know. I don't want to know.
Okay. As long as we all got 16.91, that should be correct. Okay. Who knows what the median is?
17.
17. Very good. What about the mode?
19.
Very good. Okay. Now let's begin number 5. So remember, who remembers how to create a rate per 100,000? Anybody?
I do.
Mason?
You take the total number, divide it by the population, and then you multiply it by 100,000.
Very good. Why are you going outside?
Because outside is nice.
Okay. Fair enough.
And I've been inside way too long.
Yes, I hear you. Are you in South Carolina?
I am.
Oh, okay.
Where's your
Is it not
goats?
still wet?
They're down there. No, it's not.
Oh, okay. Yeah, I guess the sun did just come out. Okay, so just like Mason said, we're going to divide the total by the population and multiply by 100,000. I want you guys to fill in the rate per 100,000. I'll give you a few minutes to do that. Please use a calculator. Do not do this by hand. And then I will check back with you. Okay, how we doing? Are we ready to share some murder rates?
Yes.
Yes. Okay, who wants to tell me the murder rate in California?
5.83%.
Very good. Not percent, it's a rate. Okay, what about Louisiana?
11.95 per 100,000.
Very good. How about Missouri?
7.70.
Very good. And New York?
$4.29.
Very good. Okay, we're getting the hang of this. Now we're going to make a contingency table. So based on these stats right here, I want you to fill in the blanks where they belong, okay? I'll give you a few minutes to do that, and then we'll go through.
When we're making the contingency table, do we use percentage, or can we use the decimal place for it? Like instead of 75%, can we use 0.75?
No, give me the percent, 75%.
All right.
Hold on, I just heard something on here. What is happening?
Wait, Dr. Hill,
Yes.
you just put you're just putting those statements in that chart?
You're putting the, hold on, let me share the screen again. Let's see. Which table are you guys seeing the one that I'm moving?
Yes.
Okay. So all we're doing is putting the percentage in.
Oh, okay.
Yeah. So this should tell you 75 people raised in the South own a gun. This part should tell you which box the 75 goes in.
Okay.
All right.
Thank you.
All right, we ready to answer this one? Okay, so what number goes in this box right here? Where my mouse
75.
is.
75.
Very good. What about this one right here?
22.
22. Are we sure about that?
Yes.
Very good. Okay, what about this one?
25.
Very good. And this one?
78.
Okay, so in general, what you're going to want to see, and when we make some contingency tables next week, sometimes there's a total row down here and a total right here. And in a perfect world, you're going to have 100% on either side. But occasionally what you find, especially, I do a lot of survey research. Occasionally it doesn't always add up to 100%. And that is because it's not uncommon for people to leave questions blank, right? So for instance, if I'm asking people to fill out a survey where they're saying, you know, if they own a gun or not, Sometimes people just leave that question blank, in which case it may not always add up to 100% here, 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 and here. So if that's the case, usually what I do is I make a little footnote or I write note under the graph and indicate that they may not add up to 100% because people left questions blank. Okay? All righty. Now, what we're going to do is number 7. So, what I want you to do is interpret the correlation coefficient. So, I want you to tell me the direction and the strength. So, imagine that our two variables are age and the likelihood of committing a crime. So, I want you to tell me, based on this correlation coefficient, as age goes up, does the likelihood of committing a crime go up or down? And is that a strong, a moderate, or a weak correlation? And then assume we're going to do the same thing with those same two variables for each of these correlation coefficients, okay? Uh-oh, Marie just got kicked off. Hold on, let me see if I can invite her. Oh, there we go. You're back? There you are. Okay. Yes, so if any of you guys get kicked off, just do what Marie did and shoot me an email and I can invite you back. Okay, are we ready to answer these? All right, so let's start with this one. What is this correlation coefficient telling us about age and the likelihood of committing a crime?
Down and moderate?
Down and moderate. Okay, so you're right, it is going down. So what does that mean? As age goes up, so as you get older, are you more or less likely to commit a crime?
Less likely.
Exactly, and it's 0.75. I would consider that to be strong.
Okay.
All right, very good. What about this one right here?
Up and weak.
Up and weak, so put it in a full sentence.
As age goes up, the likelihood of committing a crime goes up, but it's a weak
And
correlation.
it's a weak relationship. Very good. Okay. What about this one right here?
Down and moderate. So my dog.
All right, so put it in a sentence.
As age goes up, the likelihood's gonna go down.
Yeah, I would say that's moderate to weak. Some people say weak is anything 0.3 and below. If I was writing that in a paper, I would say it was a weak to moderate relationship. But if you put weak or moderate in your quiz, I would most likely give you credit for that. All right, last one.
As age goes up, the likelihood of committing a crime goes up, and it's strong.
Very good. So something that's interesting about a correlation coefficient is it goes both ways. So what you can say here is that as the likelihood of committing a crime, goes up as you get older as well. So you don't have to say it in that order. So correlation coefficient just is talking about as one variable trends, what does the other variable do? So it doesn't care which one is your independent and your dependent variable. So you could literally say it either way. But sometimes it doesn't make sense, like if one of your variables is gender or something like that. Does that make sense? Okay, so now what we're gonna do is number 8. So what we're gonna do is calculate the coefficient of determination. Who remembers how to do that?
You square it.
Exactly. Yeah. And so what we're going to do is interpret it as well. So remember, who remembers how to interpret it when you're talking about the coefficient of determination? What's the language that we use? Do we not remember that?
The variance in the dependent variable.
Yeah, exactly. So what we're going to say here, so let's do this first one together. So if we're looking at it, it's negative. What is that telling us about age and the likelihood of committing a crime? As age goes up, does the likelihood of committing a crime go up or down?
Down.
Down.
Exactly. Okay. So when we square that, what do we get?
0.3721.
Okay, very good. So what that's saying is that age describes about 37% of the variance of the likelihood of committing a crime. So if we're trying to figure out exactly what causes someone to be likely to commit a crime, age will describe about 37% of that. Does that make sense? All right, let's do the rest. So if you want to start by telling me the direction of the relationship, and then what percentage of one variable explains the other. Is that a goat, Mason? Oh my God, you have a goat? I want a goat.
We have two.
Oh my God.
They're like pygmy goats, so they get up on the table and they annoy everybody.
I expect to see your goat in every single lecture.
All right. Sounds good. They're
What-
like, they're basically dogs now.
I know. What's the name of that goat?
That is Maxine.
Maxine, what's your other goat's name?
She's Catherine. They're named after my great grandmothers. So, yeah. I don't know where Catherine's at. Ah, she's down there playing with a tree.
All right, we ready to do this one? Are people still working? Can't really tell. All right, let's do this one. What do we know about this correlation coefficient?
It goes up.
So what does that mean?
So as age goes up, the likelihood goes up.
Okay. What's our coefficient of determination?
I got like 0.64%.
Yeah, that works. So put that into a sentence.
Age accounts for approximately 0.64% of the likelihood of age to be a factor in committing a crime.
Yes, the likelihood of committing a crime. Exactly. All right. What about this one? This one will be kind of funky.
Age will be the cause of 98% more likeliness to commit a crime.
Yeah, exactly. The reason that this looks so weird, what happens when you square 1?
You get 1.
Yeah.
You get 1.
Exactly. That's why I had to do this one like 6 times before I remembered that. And then I like convinced myself my calculator was wrong. But that is why that looks so funky. Okay, what about this one right here?
as age increases, the likelihood goes up, and age describes 17% of the likelihood to commit a crime.
Perfect. All right. 2 more problems left. So this one will be really quick. Which one of these are we going to consider to be statistically significant? So I'll give you a few minutes to, if you just want to like put those in bold or something or underline them so I can tell. All right. Which ones are significant?
0.05,
Right. What else?
0.01,
Mm-hmm.
0.001,
Right. Anything else?
0.003.
Yep. What about this one right here?
no.
Nope.
Only
If
if only if, only
say
if
it.
it's in a group only if it's in a group smaller than 100.
Yeah, exactly. Because then sometimes you'll notify, like if it's 0.10 or below. But in general, we want 0.05, 0.01, and these two. All right, last problem. So using, why did I say following tables? That doesn't make sense. It's one table. Okay, so let's assume this is a t-test, which just as a quick reminder, that means that we are looking at means, so the averages. And if we're looking at if males or females are more like or older or younger when they commit their first crime. So I want you to interpret that and tell me if the relationship is statistically significant.
Dr. Hill, will you repeat what you just said, please?
To interpret this, what do you need me to like what's confusing you?
I just didn't catch what you said.
Just that I want you to interpret this t-test. So remember, a t-test is measuring means, differences in means. So is there a difference in means when it comes to gender and the age at which they commit their first offense? So are males or females younger when they commit their first offense? And is the relationship statistically significant? All right, we ready to interpret this t-test? Who can tell me what this table is saying?
That males tend to commit crimes at a younger age than females.
Exactly. And is the relationship statistically significant?
Yes.
Yes, it is.
Okay, I
Very
was-
good, Robin. I think that's Robin.
It is.
Okay, yes, very good. All right, so last thing we'll do, I just want to show you how to upload this. So let's see, hold on, let me share the screen. Okay, so to get your participation points today, what you're going to do is, can everybody see my Sit Learn screen? We can see this? Okay, so if you go over here to worksheets, your quantitative literacy worksheet right here. This will look slightly different for you guys because this is the teacher version, but what you're going to do is attach your file. So what you did today, just save it, and then you're going to browse your computer, attach it, and submit it. And you've got like another 10 minutes or so to do that. Okay? Any questions?
You want to see my other goat?
Obviously. So don't forget we have, well, Mason, hold on, let me find Mason. Where'd he go?
Yep.
I'm trying to find you.
I'm right here.
I mean, I know you're, okay, now I can. So while Mason's looking for his goat, we have a quiz on Friday, so we will not be having a Zoom lecture. I believe I give you like 12 hours to take the quiz. So you need to take it sometime before 11:50 p.m. So what you're going to do is you're going to go to your quizzes link and go in and take the quiz, and it's basically going to be very similar to the worksheet that we did today. Any questions? Okay, so I will basically be in front of my computer for the rest of the day because that is my life now. So if you are confused about something, oh, is that the goat?
Mm-hmm.
I see the goat. Oh my God, it's really cute. They're not babies, they're just pygmies?
Yeah, they're pygmies. So they'll get, I want to say they're 3 months old right now. So they'll get about twice their size that they are now. But I mean, they're still smaller than one of my dogs. So.
Oh my God.
And my dog is a Boston Terrier mix. So.
That's really cute. I can hear my husband creeping on the stairs.
But
Robert,
yeah, they'll
what are you
say. I
doing?
mean.
Okay, what I'm gonna do, I'm gonna go in here and give you guys another 30 minutes to submit your paper since we're looking at goats and my husband is flopping around on the floor out here, distracting me. So just make sure you get it in by 12:30. Even if it's a little bit late, I'm not gonna, I mean, it's literally a 1-point assignment, so don't worry about it so much. Shoot me an email if you have questions. Take your quiz sometime tomorrow before midnight-ish. And if I don't hear from you, I will see you guys on Monday morning. And Marie, did you see the different email, the follow-up? Okay. All right. So Stephanie, I'll see you at 2 today. And Marie, I'll see you at 2:30. All right. Good luck, everybody. See you later.
Thank you.
Bye.
Yeah.